Hello, 6th grade math students. This is chapter 11.3, Real-World Problems with Circles. There are some really fun real-world problems involving area and circumference of circles that let you use your visual problem solving and your logic skills. Let's get started. Let's begin this fun by using the formula for circumference to solve some real-world problems. A circular mat has a diameter of 53 centimeters. So the diameter of this circle is 53 centimeters. Lily wants to sew a decorative braid around the mat. How many centimeters of braid does she need? Give your answer to the nearest tenth of a centimeter and use 3.14 as your approximation for pi. Circumference is what we're looking for here, right? Because she wants to sew a braid around the outside edge of the mat, so we need to know the distance around the mat. Our circumference is equal to pi times diameter, so 3.14 times 53 centimeters will give us the length that we need, correct? So Lily will need 166.4 centimeters. When you multiply it all the way out, you actually get 166.42, but the directions tell us to round it to the nearest tenth. So our answer is 166.4 centimeters of decorative braid. All right, now this is where it really starts to get fun. A metal worker cuts out a large semicircle with a diameter of 28 centimeters. Then, the metal worker cuts a smaller semicircle out of the larger one and removes it. The diameter of the semicircular piece that is removed is 14 centimeters. Find the distance around the shape after the smaller semicircle is removed. Use 22/7 as your approximation for pi. Okay, so what we're looking for is this length. This. If we could wrap a measuring tape around that, what would the measurement be? All right, so to find the distance around the shape, we have to add up the two arc lengths. We need to add up the length of arc PQ, and we need to add the length of arc PO. All right. We know how to solve for both of those, so let's get to it. The length of a semicircular arc is 1/2 of 2 pi r, or 1/2 of the circumference, correct? So our semicircular arc PQ is going to be equal to 1/2 times 2 times 22/7 times 14, correct? All right, so PQ is going to be equal to, let's work this out here. We can reduce these. All we have left here is 1 times 22 times 2, 44. So our arc length here is 44 centimeters. All right, we have our first answer. Let's go on to the next piece of the puzzle. And the next piece of that puzzle is finding the length of PO. So we know the diameter of PO, so the length of that semicircular arc is going to be 1/2 times pi times diameter, or 1/2 times 22/7 times 14, correct? Again, let's reduce where we can. Which leaves us with 1 times 11 times 2, giving us 22 centimeters. So now we know the length of this line is 22 centimeters. So the distance around the shape will equal PQ plus PO plus OQ, this line right here. Let's do it. PQ is 44 centimeters. PO is 22 centimeters. OQ is 14 centimeters. Add it all up, and what do you get? 80 centimeters. So the distance around the entire shape is 80 centimeters. Okay, friends, here's another fun one. The shape of a tabletop is made up of a semicircle and a quadrant. Find the distance around the tabletop. Use 3.14 as your approximation for pi. Okay, we need to solve for this length, and for this length, and we have all the information that we need to do it. First, let's find the length of our semicircular arc, which is QO, this length right here. The length of a semicircular arc is 1/2 pi times diameter. So let's plug in the numbers we know. 1/2, we're using 3.14 as our approximation for pi, and our diameter is 60. So QO is going to be equal to 3.14 times 30, or 94.2 inches. Okay, so now we know our first distance. QO is 94.2 inches. Next, we need to find the length of arc PQ. That's going to be 1/4 of the circumference of that circle, correct? Because it's a quadrant. And for this one, we're going to use 2 pi r because we have the radius of that circle. So let's plug in what we know. PQ is equal to 1/4 times 2 times 3.14 times 60. Okay? We can do a little bit of reducing here. 4 can become 1, 60 can become 15. That'll clean this up a little bit for us. So PQ is going to be equal to 1 times 2 times 3.14 times 15, which gives us 94.2 inches. Yes, indeed, I used my calculator to calculate that. Hey, do you notice something really interesting here? The length of this quadrant and the length of this semicircular arc are the same. Pretty cool, huh? All right, so now to find the overall distance around the tabletop, we need to take length QO and add it to length PQ. And don't forget, we need to add this distance too. Length QO was 94.2. Length PQ was also 94.2. And the length of line PO is 60 inches. These were all inches. Sorry, I forgot to put my labels on there, didn't I? Oops. And once we add this all together, we have 248.2 inches. Okay, folks, give this a try on your own. In problem number 1, the circumference of the moon is the approximate distance around a circle with a radius 1,736 kilometers. Find the circumference of the moon given the information here. In problem 2, you have a greeting card that's made up of 3 semicircles. O is the center of the large semicircle. If you wanted to decorate the distance around the card with ribbon, how much ribbon would you need? You can round your answer to the nearest inch. There is one more practice problem on the next screen, so press pause while you work and move on when you're ready. In practice problem number 3, Sally bends a length of wire into the shape shown below. The shape is made up of a semicircle and a quadrant. Find the length of the wire needed to create this shape. Once again, you're looking for the length of a semicircular arc and the arc of a quadrant. And don't forget to include the straight line when you add it all together. Both straight lines to be exact. All right, good luck with this. Press pause while you work, and when you come back, we'll solve some real-world problems using area of a circle. Now let's solve a problem involving a piece of jewelry. A jewelry designer is making a pendant. The pendant will be a circular disc, center O, with a circular hole cut out of it, as shown. The radius of the disc is 35 millimeters. Find the area of the pendant using 22/7 as your approximation for pi. Okay, so we know our radius of our disc is 35 millimeters. Let's label that too. We can simply solve this by finding the area of the larger circle, then finding the area of the smaller circle and subtracting that away. Let's begin by finding the area of the larger circle. The area of the overall disk is going to be pi r squared. So let's plug in what we know. Pi is equal to 22/7. Our radius is 35 millimeters. Okay? There are two different ways that you could think about doing this. You can either first square 35, then multiply by 22 and divide by 7, or you know how much I love cross-reducing. I'm going to rewrite it so that I can cross-reduce. So pi r squared is equal to 22 over 7 times 35 times 35. Now I can reduce this, and I have 22 times 5 times 35, which gives me 3,850 millimeters squared. Okay. Now let's find the area of the hole in the pendant. That is also going to be equal to pi r squared. So pi is 22/7. The radius of that hole is the diameter times 2, right? The diameter is the radius of the larger circle, so the diameter here is 35 millimeters. So we want 1/2 of 35 millimeters, or 17.5 squared. All right, so now I have 22/7 times 17.5 times 17.5. I guarantee you I'm going to use my calculator to figure that out, and the answer is 962.5 millimeters squared. Final step. We need to find the area of the pendant overall. So we're going to take the area of the disk, 3,850 millimeters squared. We're going to subtract the area of the hole. Oops, I just noticed I left out an M there. The difference between these two will give us the overall area of the pendant, which is 2,887.5 millimeters. Sorry, I ran out of space to write down our units there. So 2,887.5 millimeters squared is the area of the pendant. Okay, let's try another problem. Let's work another one of these fun logic problems. A graphic designer creates a design for a company logo. The design is a green semicircle with a white quadrant, as shown. Find the area of the green part of the design using 3.14 as your approximation for pi. Okay. This works very similarly to the pendant problem that we just completed. First, we're going to need to find the area of the overall green semicircle. Then we'll find the area of the white quadrant, and we'll subtract that away from our area of the green semicircle. That will give us the area of the green area that's left. Okay, so let's begin by finding the area of our semicircle. And that area is going to be 1/2 times pi r squared. Or because a semicircle is just half of a circle, therefore the area will be half of the circle's area. Alrighty, so let's go ahead and plug in what we know. 1/2 times 3.14 times our radius, which is going to be 160 squared. I'm definitely going to use my calculator to figure this out. And my answer is 40,192 millimeters squared. All right, so that is the area of this. Now, let's figure out the area of this. So the area of the quadrant is going to be 1/4 of pi r squared, correct? So 1/4 times 3.14 times our radius squared here is going to be 30, right? See here that our radius for our semicircle, our quadrant is 30 millimeters. So let's go ahead and plug that through It's okay to use your calculator for this. You'll first want to square 30, then multiply that times 3.14, then divide by 4. That will give you the correct answer. And the correct answer is 706.5 millimeters squared. Now we finish up. The area of the green part remaining is the area of the semicircle, 40,192 millimeters squared, minus the area of the white quadrant, 706.5 meters squared, which gives us a remaining area of 39,485.5 millimeters squared. Look, I forgot my extra M up here again. Oops. Sorry about that, guys. So here is the area of this green portion. Here are 2 practice problems for you to attempt. In number 4, Judy baked a pizza and had a part of it for lunch. After the meal, the shape of the remaining pizza is made up of a semicircle and a quadrant. Find the area of the remaining pizza, which is represented by the green portion of this figure. In number 5, we have a rug that's made up of a quadrant and 2 semicircles. Find the area of this rug. These 2 problems wrap up part 1 of chapter 11.3. I'll see you tomorrow to do more work on area and circumference of a circle being used to solve some real-world problems. See you then.